to be more involved with ideas. So problem solving is a skill that we're always developing and really always working through as developers. We're looking for ways to, we're looking at what the world ultimately is lacking and how we can impact that. That is what we are looking for. And so we should always be looking for that skill to promote, right? So being present, paying attention to others' perspective, looking for things that other people complain about is another thing that I really think that I see as a way to find new ideas. Where are people finding struggles? What needs to be brought up? These are the places where I kind of think of them. But not all ideas are going to be revolutionary. It can be as simple as, oh, I found this cool API, and maybe I want to execute something with that API. I'm working with something on movies. It is not the coolest API, but it is an API that I really enjoy working with. So it can be really simple and really bare bones of where ideas for apps come from. Most ideas will stay in your notes. This is just the way that it works, and that's okay. Ideas aren't going to be revolutionary every time, but they're going to be worth at least writing down and maybe going back to on with some time. So keeping track, how do we do that? So pen and paper is the most simple thing. This is like bare bones, like where do we start? I keep one in my pack at all times. I keep them by my nightstand. It's astounding how many little notebooks that I have of just like pen and paper just everywhere. Post-it notes are another great way. I have them a huge stack by my desk and hang them by my monitor all the time. Software, and we're going to get more into software of how to really track these ideas and a little light about how to use them. Because our end goal at the end of all of this is, to me, I think about it as, I really want as little time in between the idea of when the thought is actually, it comes into my brain and writing it down. Because I think there's something in that moment. When you're in practice, you're able to capture something. And you're going to need these notes because who knows when you're going to be able to execute such an idea. So you're really going to need some time to really think through. And I think there's something to mentioning that. So the apps. So Evernote. Evernote is a ubiquitous app. If you have not used it, it is everywhere. You can use it on iOS app, or iOS, web, Mac, Windows, it's everywhere. The really nice thing about it is it's simple notes. If you know how to use Google Docs, if you know how to use Word, you know how to use this. So it's already something you're probably familiar with if you have not used it. But I think there's a better program called Drafts. Drafts is a really great program. It's in the iOS system. They have complications and everything for your watch. It's Evernote, but with more options. You get a lot more to play with. It's really nice. So Evernote. This is kind of what Evernote looks like. This is my ideas. So like creating a new note, you can see it kind of takes a little bit of time. It takes a few clicks. I think it could be better. So app idea, you always get the Instagram for X. This is always people give you this idea. So Evernote. So it's a unified system. It's really nice because of the web app. You can just use it everywhere. So whatever you can use a web browser for, it works. It's as simple as they come. It's a good place to start just because it's just so approachable. I think it's so easy. But I think there are better ways, and we're going to go through that as Drafts. So Drafts, you just launch your window, and boom, you're into a new note. It's instant. You don't have to think about anything. It's just there. You just launch it, and same thing on the phone. All right. So what they call is instant capture note taking. So once you launch it, it is up, it is ready to go. You are taking your notes right then and there. You get access to Markdown in this, so you can really customize the way that things are looking. I really enjoy using it to make like READMEs for my GitHubs and stuff like that. It's really great. You can get preview windows, and there's a lot of what they call customizable actions. And these actions are basically add-ons to your note so that you can make really easy lists. You can do a lot of really interesting stuff because it's a very plain looking file. You get offline usage with this. So if you're out and you have your phone only or your watch, you can just, boom, you can just hit it and make a new note, and it'll save it for you. And there's a really great workflow when it comes to drafts that go into a shortcut and eventually go into Notion is another program we're going to talk about because you get access to Notion's API. And there's a whole workflow that you can set up just using drafts together. There's a lot of great information. All right, so now that we have our idea and we have it written down, we need to figure out how are we going to figure out what do we want to make first. So we have 30 ideas. What do we want to do? We want to do something that's in our wheelhouse, right? We want the idea that we're going to be working on to be something that is going to stretch us as developers, but it's not going to be overwhelming. It's going to be something that we can accomplish. We have to establish what are our knowns and our unknowns. So we have to understand what are the things that we do know, what are the things that we don't know that we're going to have to cross. We have to start thinking about these things so we know which thing we really want to do. Is this a portfolio piece? Is this something that's you're going to add to maybe help you get hired? Is this just a straight business? Like, is this something that can become eventually a company? Is this just something for fun? I think at the end of the day, it's really important to keep in mind that what you're doing, that you're, I don't know, I really enjoy app developing. And so I look at it as a lot of fun to dive into something. And so having that spark of creativity and just doing something out of the interest of doing it. Another thing to keep in mind is what is your timeline? How long are you going to be thinking about this? How long are you going to be working on this? You can reestablish this as it goes, but keeping these things in mind, I think, is really important so that you're kind of sticking to something, you have some sort of standard, but this can always be revised as well because you're going to run into things that you just have no idea that you knew. A huge disclaimer, the process can take months. Make sure you like the idea, all right? I think this is maybe the most important thing because something that I found when I first started developing was people would come to you with ideas when they found out you were a developer. And you would get these ideas that you're like, oh, that is an interesting idea, but I don't know. And then you start working through it. And then you're like, I don't have any attachment to this. I have nothing here. It's just somebody's idea that I'm working on. So when you're choosing something to work on, make sure that it's something that you really, really want to do. And I think I've kind of made it a point now to not work with other people's ideas, at least for my personal projects. I want them to be something that I've come up with, something that I'm interested in, because it feels like I've unlocked a new thing. Because once you start doing it, start getting into the rhythm, you really start to find a way forward. So after we have our idea established, this is where our iteration comes in, our refining process. All right. To me, ideas are worth nothing unless executed. They are just a multiplier. Execution is worth millions. So this is where we really get into our, this is where the rubber hits the road, kind of. So sorting through ideas. So what we're really doing in this iteration stage is we're taking abstract ideas and we're actually making them concrete. So we're going out and reaching out into the ether. And this thing that we have thought of, we actually have to put it in a device in someone's hand. And so I think this is where we start to really hone in on what we want features and things to be. And this is going to be our first pivot points with many to come. So we're going to have to think through ideas, or think through the implementation of these ideas that we really want to make, so the features that we're going to be adding in. We're going to have hundreds, if not thousands, of decisions through the entire process. And so this iteration part is really honing in and really focusing in on the features, the set that makes up the idea overall. And I think this is a really good time to remember, because this may be months after. But remember that you're starting from an inspiration of some sort, where you saw something. Try to remember these things, because that will help you give context and take you back to that moment where you originally thought of the idea itself. All right, so this is an app that I'm currently working on. This is where I took my original inspiration from. And so you'll see in the iteration that you kind of start with work that's already been done. So this is from another app that I really enjoy called Letterboxd. It's kind of like a social IMDb. It's basically the easiest way to put it. So I kind of took inspiration on the first version of a screen. It's like, okay, this is all the information I have access to onto the API that I'm using, but I can make it work. I really like the layout of this. I kind of like how it looks. And I think this is good enough to launch with. I think somebody would, this would be okay to launch with. But then we get into like a version 2 of what something would look like. And now we're starting to get a lot more information, and something that is just, I think, is a way better design. And so you kind of had to start at one place, make it your own, and then iterate upon your own thing. So the apps. So how are we making this stuff? So Figma. If you're not using Figma yet, this is, I think everyone should be using it. It's free, as long as you're not working in a huge team. And it's available everywhere. So you can use it on iOS, web, Mac, Windows. And it's a really good testing ground, because you can, we'll kind of get into it, but you can really test out your UI UX in it. And then Keynote. So we're available on iOS and Mac. It's very quick and dirty, but you can do it. If you don't want to write a line of code, or if you don't want to fiddle with XY coordinates, if you don't want to do any of that, you just want to plug and play, I think Keynote, you can get actually a lot done. So getting into Figma, this is what a Figma screen looks like, and we'll kind of get into breaking down a little bit of what it is. So Figma, we're designing our UI UX, so how users are going to be interacting with it, where our buttons are going to be, what our views are going to look like, all these types of things. We can really prototype. This is the thing I think sets Figma above everything else. It's because you can start prototyping with it. You can get it in somebody's hand, and then they can swipe through stuff, and we'll kind of go through that. And you can see how people react to it. You can share it with people. You can send them links and say, okay, hey, can you look at this? Can you launch this? How do you like these buttons? How do you like how these things interact? And then a really great thing about Figma is that they have these templates that are available to you. So you can make like your app icons in there. I've made my resume. That's a whole ton of features that are just in this one design application. But just like a sketch. It's really similar to that, but it's a free version of it, and you can make your app icons, all kinds of stuff. All right, so in our screen, you'll see in the top left that this is basically where where we make our views and we make our screens and everything like that. Then we have our screens that we have laid out. You'll see a view for each one here. Within that, then you have your actual views and how you set them up and what they look like. So you can see that the movie details, the one to the furthest right, has all kinds of information. And then we get into like our XY coordinate stuff, what we want our views, how big they need to be, all this kind of stuff. Our color scheme. And this next part, this is my favorite part of Figma. And I think that this is why you should be using this tool. 'em, alongside. So what we do is we're able to, look at our button, and then we're able to, on tap, we have a bunch of different options that we could do. We can navigate to, and then we want to go ahead and navigate to our schedule, because we're going to be scheduling a movie. We have different ways to do that, different ways for the view to appear. And then when we launch into our view, we can see this is our list of future movies, and then we click on a cell, and then we're able to see, okay, that's the movie that I want to see later. You can add it to your schedule, and boom, we'll see it added to the schedule and what that view would look like once it's added to. All right, and so for Keynote, so this is something I think, I don't know, I found a random WWDC talk about this, and I don't think I'd ever use this, but I like that it exists so that anybody can approach it. It's dead simple. So we have, it's a really quick and simple UI, simple UX testing. You basically use the app interactions as a slideshow. So somebody tapping on a button would advance a slide. And I included the actual talk. It is not on WWDC's website, by the way. It's not in there. First, who knows why? It just doesn't exist. So it lives on YouTube now. Okay. And so this is what they kind of go through. They show you the inspiration. So they started with their music app, and then they're making a toast app. And so this is what the toast app, this is, yeah, the toast. And they kind of show you how they steal from each other to make that new layout design. And so you're able to make a list view, you're able to make a collection view, you're able to make maps. You can do all of this stuff within Keynote itself. It's really, really nice. So you can get kind of a hybrid of a collection view. All right, so now that we have our idea and we've iterated, we kind of thought through, okay, these are the things that we want to include, these are the things we want to leave out. Now we need to actually implement those. This is where the really heavy thinking comes in. So the execution of all plans. So most leaders would agree that they'd be better off having an average strategy with a superb execution than a superb strategy with a poor execution. So the apps. So we get into Notion. This is an app I'm still learning, and there seems to be a lot of depth with what you're able to actually do. You're really able to organize chaos because when working through stuff, it can be, at least for me, it is quite a storm in your brain of like, where do I start? How do I do this? I want this to be done. I want that to be done. And so it can really help take your brain's processing and kind of like just spit that out into a UI, which is really nice. And the one that I've used previously, which is Trello. I really enjoy Trello, but I think Notion just has more to it than Notion has more to it than Trello. So Notion. So this is just our post idea planning. We're kind of setting out. We're looking at task lists. And you're kind of setting up these tickets for yourself. And from this, you're basically creating your roadmap of starting from nothing, and then eventually all of these ideas are going to be completed, and it's going to be a fully featured working app. You can use it for project management, which is really nice, so you can assign things to people. If you're working in a team environment, let's say that you need certain UI things done, certain UI design need to be done so that you can implement it in your app. And you can share this with people. It's really, really great stuff. And it integrates with drafts. So the way that you can set it up is so that basically drafts works with the Notion API, and you can type out your drafts in a certain way so that when you import it into Notion, it'll just have all your tasks and everything set up. It's really interesting. This is kind of what the layout looks like. So you can see that there are different stages of where the app is in the process and different features and who they're assigned to, what the timeline looks like, these types of things. And this is part of like a templated system that you just have access to in their whole ecosystem. It's really, really cool. Then we have Trello. This is what I've used the most. These are like projects that I've worked on in the past and kind of our layout. And when you get into one of these, this is kind of what you're looking at. You're looking at basically the way that they would structure the sticky note system. So it's kind of like that, but it just doesn't have everything that I'm looking for. I think Notion has it beat out. But I think if you look at Notion and it looks like too much, I think this is a good place to start. So you're setting your roadmap. So you're setting your MVP. So MVP, if you're not familiar with it, is minimum viable product. This is, what is the minimum threshold that I need to meet so that I can ship an item, so I can ship a product. This is how you need to really think about app development, and especially in the early times of when you're developing something and sending it out. The thing that I've been told is that you should be embarrassed by your 1.0. If you're not embarrassed by your 1.0, you're probably shipped too late. So know that it's okay to, it's not to be happy with everything, and exactly everything is thought through and in place. Because you're going to get feedback, and you want to be able to integrate that feedback. So working through the tasks you need to complete to reach your MVP. That's the point of setting these roadmaps, right? So we have the end goal of all these things. Now we can start working through these. You're going to find that these task categories are really going to help you out. So you have a feature branch, and then you have like what you're working on currently. Okay, now that I've worked on it, I found these bugs in it, so now I need to debug it. Once it's debugged, I can complete it. And then there are going to be things that you find that are not part of your MVP. And so these can be part of a future release. So you just put them into a future thing. And then you're going to come across ideas, features where you're just, this doesn't make any sense anymore. I don't know why would I include this. And you can just scrap it. And so this is how you kind of organize your roadmap so that you know, okay, now I can launch. I'm good to go. One thing I think is very, very important is ensuring that you're giving yourself extra time to learn new skills in this process. I think that is a great part of developing, is you get to learn all these new things and integrate just these things you're not familiar with to be able to give you a larger feature set to offer when you're looking at companies and this type of thing. And then also budgeting for boilerplate work. So you're organizing, you're adjusting goals, adjusting features for launch, and just overall reworking your game plan. I know when I was first starting to work through ideas, I was not putting enough time towards this type of thing, because you just think, oh, I'll just get that done on this time, or I'll just get this done tomorrow. And it keeps kind of putting, but it all adds up at the end of the day. And I think it is really important to keep in mind that you are your boss during this process, that you are in charge of the whole thing, you are the captain, and that you're able to say, I don't want this anymore, and it just doesn't make sense to do it right now. And to know that you're the one making these decisions, and you're the one making these decisions, and your ultimately is going to be reflective upon you. And follow me at Tyler Perkins on Twitter. I'm looking to get more users. And that's all I got. All right. So any questions, I guess, is where we go next. Yeah.
Well, I have a question. So you said earlier on in the presentation that most of your ideas will kind of stay in your notes kind of graveyard.
Yeah.
What happens to ideas that get past that but don't quite make it to a product?
So I think what I've found working through is that when I start putting my feature set together and really loading my Trello board up with features and things like that, if it's something that, if I find that I'm not able to really conceptualize how a feature or main component of an idea is really going to work, I think that's a really good way, or maybe you don't have all of the necessary tools in your toolbox just yet to execute in the way that you want to. I think that's a really good way to know, okay, maybe this idea needs to be put off. But I think even going through those steps and having all of that stuff for reference in the future is going to be good as well. So that you have those feature sets and you know what you were thinking at the time, and including in your notes, this is the feature that I think is going to be holding me back from launching this app. And sometimes it can just be pushed off into the future. But if it's part of a feature that it needs to launch with, that is part of the MVP, it is. I think that all of that work is good work because it's showing that there is substance to the idea. But it's just as valuable to come back to it 6 months, a year, 2 years later, and to have a record of why you kind of put it off. So I think finding it in the part of the process is part of the process, I guess.
Thank you.
Anything else?
There.
Yeah.
Hey, Tyler. Yeah, my question is, like, what's some of your favorite like sites to go to kind of get the juices going for ideas, like maybe like portfolio websites or something like that?
Yeah. So Dribbble has been like the go-to for how long has that website been around? I feel like it's been like a decade or two at this point. But yeah, Dribbble is like, I like looking at UIs, and so just seeing that can really help, like, because it's really interesting about ideas is because something can just be sparked and you have no idea why you thought of it or where it came from, and it can just be looking at something. And so I think thinking of ideas is something I'm always thinking about, and so I think with that in like deep in the back of my brain, I think you just get inspired by living and trying to exist and taking inspiration from people around you. The other one, I mean, they're not, and like I said, they don't always have to be like these revolutionary ideas. And there was a great GitHub repository that just has all these open source APIs. I'll find a link for it and I can let you know, but like, I'll include that with this stuff. But it just has all these open source APIs that you can just go into and say, oh, there's like one that was about beer. There's one about, there's a really cool Marvel one. And so just finding these things that you didn't even know you had access to is just being open to discovery. I think that is the fundamental of finding new ideas and being inspired. Just being open and just, I don't know, just thinking about the idea of ideas a lot.
I agree.
Yeah.
Yeah, that's a good answer. Appreciate it.
Anybody else?
So how deep do you go into planning before you start building anything?
So the iteration, I mean, it can be really spread out over months. It really depends on what's really hitting you at that moment, because I think you're going to go through waves of you're excited about one thing and not excited about another thing. And I think a big part of is documenting, probably documentation and leaving documentation for your future self. And let's see, is there anything? Documentation for self, I think, is super important in the process, and leaving those notes in your roadmap, I think, is really super important as well. I feel like I did not answer your full question though. What was?
Yeah, so how deep do you go into planning? Like, when do you know it's time to start building?
Oh, okay. Yeah, so when you have, what is the easiest way to know when to start building?
Because I know some people want to just jump into the code like as soon as possible, and I think you should spend more time.
Yeah, definitely. I think you should hold back. I think once you have thought through all of the roadblocks you can think of in your app idea, I think that's when you probably should start building and start getting some of your views together and really working out the roadmap and what your feature set is going to look like. So once you can really set like what's the littlest thing that I need, I think that's a good place to start. And you're just going to naturally run into roadblocks, and you may get into development, and you're just going to run across something, and you're just not going to know how to overcome it at that point. That's okay. But I think, maybe I should include this, is using Git to leave yourself notes on the breadcrumb trail of the things that you've been developing and know why you've been developing, so you can think about them later. But I think essentially is just when you feel comfortable that you have a feature set that reaches an MVP, I think that's when you start developing. And just know it's okay to stop development on something when it's not inspired and you're not feeling it and you need to move on to something else. Because I burned myself out the first time I was really working through Swift and trying to understand it. And burnout it'll make you hate a lot of things in code. You'll hate to look at your IDE. So managing burnout by remaining inspired, I think, is really important.
All right, well, my name is Richard. If you don't know me by now, this is likely your first time here. And I'm going to be doing a presentation on building with SwiftUI and concurrency. I do have a foot injury, so if I pause for a dramatic effect, it's just to process a little bit of pain. So we're going to dive into this a little bit. And for a little bit of clarity, when I say concurrency here, I mean more of the new Swift asynchronous features, not necessarily using the deeper concurrency features here, and we'll look into that here in a moment. So let's look at some of the older stuff. So we'll look previously on Swift. We'll look at Grand Central Dispatch and how maybe you've done this before in either UIKit or even SwiftUI. So when writing asynchronous code or trying to do even concurrent code before, we're used to using tools like dispatch queue. Of course, it's very common to see dispatch queue main async to do anything back on the main queue if we're updating some sort of property that needs to be something UI related. To do more complicated things, we might use a dispatch group or a dispatch semaphore or a dispatch source for trying to group things together and make sure they happen kind of sequentially. We might use an operation queue. We have to be really careful with some sort of things that we might do and use locks to make sure that we're not accessing things concurrently in some cases. So we might use an NS lock or an NS recursive lock. And these can get pretty complicated outside of just your standard dispatch queue things with Grand Central Dispatch. So they're not necessarily very easy to use in some cases. We did get some newer tools with iOS 13 and the other appropriate Apple operating systems and above with Combine. SwiftUI uses Combine quite extensively under the hood. And italicized, it is easy to perform time-based operations with Combine. And Combines is really easy to compose different things with, so different operations, which is great, because that was very difficult to do with Grand Central Dispatch, which is why we needed all the different things like a dispatch queue and operation queues and things like that from the previous slide. We needed all those different kinds of tools because composition was very difficult in Grand Central Dispatch if we needed to have those different kind of operations happen in different ways. With Combine and functional reactive programming in general, that's something that's quite easy to do and structure together. But the biggest problem with Combine is it's not structured. It's declarative code, and so it doesn't read like structured code top to bottom. And by structured code, I mean code that we kind of write day to day when we have if and else statements, and we have for loops, and we have while loops. That's kind of structured code, right? You kind of read it top to bottom. Combine doesn't read like that. And because of that, functional reactive programming in Combine has a very steep learning curve. There's a lot of gotchas with Combine, and it's not very easy to learn out of the box. There's a lot of moving parts, and so it's not very intuitive to just read. So with iOS 15, and then later backported all the way to iOS 13, we got Swift Concurrency. And if you watched anything with WWDC last year, you heard a lot about Swift Concurrency. So it's almost been a year since this has been released with Swift 5.5. We got a lot of new tools to make this a reality. We got async await, we got async sequence, we got actors, and in particular what's used a lot is the main actor. We got task and task groups. Task if you want to kind of spawn up your own async context from a non-async context. Task groups if you want to group things together and do concurrent things kind of in tandem. And SwiftUI in particular got a new task modifier. So we're not going to go through all these today. This presentation is actually not going to be very long from a code perspective. But these are kind of the main building blocks of Swift Concurrency and the new asynchronous tools that we have in Swift now. There's a couple more that aren't on this slide, but not too many. This kind of comprises the majority of them. And some advantages of the new Swift Concurrency system are, there's a lot of them, but these are just a couple. You can use very natural error propagation. So you have try and throws, which is just part of the Swift system in general. You don't have to use complex things like maybe optional errors inside of function signatures, or maybe a result type that might be a generic over some sort of value, or maybe has an error that maybe is typed or not typed. There's no more pyramid of doom, right? It's pretty common, especially in using Grand Central Dispatch, where you have something that's dispatched, and then you get a result for that, and that's dispatched, and so you have these kind of closure pyramids that kind of keep going down. There's a lot of compile time safety checks that we get with Swift Concurrency, all the way down to checking to see if we are using something on the correct queue or the correct thread. And so that's something that we never got before. So maybe we would get a purple warning that would show up at runtime if we were trying to update something on the wrong thread. But sometimes that can actually be checked at compile time now. And moving forward, as we get closer to Swift 6, even more of that will be checked at compile time. So that's great. There's new things like the sendable protocol that help with that. It's really easy to pass around async closures. It's just as easy to pass around as regular closures. That's something that is not easy to do with Grand Central Dispatch. It's not easy to pass around closures that are wrapped around in a dispatch. It's not really even possible. And so that's something that's really nice. And it's really easy to start something in an async context with task if it's not already in an async context. Or if you are in an async context, like already in an async method or function, you just inherit your async context from where it's being spawned from, which is really nice. You actually, for instance, if you're in an async context that's on the main actor, well, then you're going to inherit that from where you are. Or if you have a certain priority that's inherited already. That's something that we didn't get from, for instance, Grand Central Dispatch, or from before that we had threads. It wasn't in, part of that as well. So again, we're not going to go through everything with Swift Concurrency. This is not a Swift Concurrency talk. This is a kind of how to use Swift Concurrency in SwiftUI part of it, right? We're not going to go through everything. This is not necessarily a deep dive in Swift Concurrency. But we will go through a small demo of some of these features and how you can use them instead of using Grand Central Dispatch and instead of using Combine. So we will switch over to a demo here, and we'll talk about how this works. So let's first of all look at this app that we have built here. And we'll look at the app. I don't know if the audio will go through here. That's something I meant to check and forgot. But we'll see. This is going to be strange if you don't have audio. So we'll see. We'll turn it up and see. The audience here will hear it. I don't know if the stream will hear it. So this is a Simon Says game called Swift Says. So it goes through here. And so it's just a Simon Says game. It sounds great on the TV. And that's it. So it's a Simon Says game. We can play along. I'm not good at Simon Says. And we can reset and we can start a new game and things like that. The starter version here is built using just Grand Central Dispatch. So your regular things with dispatch queue and things like that. So we'll look into how this is built. It is all SwiftUI otherwise, though. It's just built using Grand Central Dispatch. So we're not too interested in the UI with this talk here. This is not a how to build things in SwiftUI talk, though I do like those kinds of talks. So what we're mainly interested here is in the observed object here with game, which we'll look at here in a moment. But otherwise, we will look at modifying some things in the UI, but we're not going to look at that quite yet. We have the user interface broken out into some views here. And what we will look at first, though, is this game object, which is an observable object. So let's go ahead and jump into that. So this is an observable object, and it's got some published properties. And we've got some things down here. The first thing we're kind of interested in, though, is this pretty big method here called highlight game inputs. And if we look back at the game that we were just doing, when we start a game, the game kind of plays back what we should do next, right? That's how Simon Says works, right? So it says, tap red. If we remember correctly, we'll tap red, maybe tap red twice. And so that's how Simon Says works. But for this to work correctly, the game has to emulate pressing the buttons before we can, right? So it has to emulate highlighting those round buttons. That seems pretty simple, but it's actually a little complex because it has to highlight those cells asynchronously, and it has to do that in a way where it's not blocking the thread per se. And then while it's doing that, it has to wait. But it's actually a for loop where it has to create those. And so we have this starting off with the dispatch main async after, because we want some delays in between there. So we want to wait before we start that operation for half a second. And then because we have this in a closure, we have to capture self weekly, or we should capture self weekly, because all observable objects are actually classes. So we have to capture self weekly here. So we have to do our ceremony of guard let self equal self. We could do an unknown self if we want to, but we have to do this. We should do this. We want to allow user input. We want to change that to false, because while the game is playing back what we should be doing, I forgot this already. I think it's red, red, blue. While it's playing back here, we don't want to be tapping here. So I'm tapping there, and you couldn't see it until I failed the next one. So we don't want to be able to tap while it's doing its playback operation. So we want to turn that to false. Then we want to start an operation queue and make sure that its max concurrent operations is equal to 1. And the reason for that is because we're going to go through a for loop and make a block operation. And during this block operation, we want to create a dispatch queue. And it's OK, you don't have to follow along this. And then we want to enter a dispatch queue. And every time we enter a dispatch queue, we have to make sure we have an exact number of leaves for our enters. And we want to do that because we want to dispatch again. We don't want to do this synchronously. We want to dispatch again. And when we dispatch again, we want to set our highlighted tile to whichever one's going through this for loop of game inputs. Because the game inputs might be like red, red, blue, or it might be red, red, blue, green. It depends on how far we are into the process. Then we want to play a sound. That's also going to be an asynchronous operation. And then we want to wait a little bit. We want to wait a third of a second. Not a third of a second, but 0.3 seconds. But then this is actually an asynchronous block. So I don't know if you noticed, but we also captured self-weekly and unwrapped here again. And we got to capture self-weekly and unwrap here again. We want to set the highlighted tile to nil. We're done after that 0.3 seconds, right? We want that to highlight and then unhighlight. And then we want to wait 0.1 seconds and then leave the dispatch queue. But because this enter and leave aren't happening synchronously, we actually, outside of here, have to wait for that dispatch group because it's not going to leave that dispatch group on the same queue. So we have to enter and then leave, or enter and then wait, because we have to wait to leave it. Then we have to add that operation. And then we have to add another operation because after all of this is done, we actually have to set the user input back to true. So this is quite a bit of code for something that seemed pretty simple. It seemed like it was just going through that loop and highlighting those tiles. You could do this in Combine as well. We're not going to show a Combine version of this, but you could do this in Combine. It wouldn't be as complicated in Combine. But again, I really like Combine. Some people really like functional reactive programming. But that kind of comes with its own overhead. If you have a team that you're working with, it's kind of a team decision on if you want to adopt that pattern, either for certain parts of an application or maybe for an application pattern as a whole. So we're going to start here in transforming this application to be asynchronous in the Swift concurrency kind of sense of that. So we'll start there. To peek at some other places of the code before we start changing this, we don't have too much other asynchronous options happening here. But we did have that play sound happening. So this play sound, if we jump over, this has an audio player. So we do have an audio player over here. And this audio player is doing some AV audio session stuff that we don't really care about. But the one public method we have here is a play sound method. This play sound method is happening not on the main queue. It has a global async after where we're doing a 0.3 second wait. And then we're playing the note originally. And then after 0.3 seconds, we're stopping the note. Otherwise, we're not really, this is definitely not an AV audio session talk because, right, I barely got that to work. So we're going to start here. The first thing we're going to do is make this whole method an async method. This kind of gives us access once we have this as an async method, and stuff's going to break before we can get this fully compiling. We're going to make this an async method, and if we make this an async method, now we have kind of access to the Swift concurrency world. So now that we have an async context here, we can really break down what we're trying to do in this method and try to write it in a structured concurrency way from top to bottom and see if we can make this look a little bit more simple. I do have an extension here that makes one thing a little bit easier. There is a sleep method that we can write in async await called task.sleep. What that does, it just allows us to kind of pause execution for a moment. So similar you would do with like thread.sleep or just sleep in general in Swift. But instead of blocking the main thread, it will asynchronously wait a certain amount of time. So it's actually desired to use it. So if you want to wait, it's kind of like a dispatch queue main async after 0.3. We can actually do like a thread.sleep 0.3. The only reason I have this help with method though, is that this actually takes nanoseconds, and that's ugly to write. So I have a version that just takes seconds as a double. So to make this a little easier, right, we'll do that. So instead of doing a dispatch queue main async after 0.5 seconds, we're going to do a task.sleep for, instead of using nanoseconds, we're going to use seconds. And we want to do 0.5 seconds. So this is an async method here. So if it's async, we have to await it. And a little bit strangely, sleep is also a throwing method. So we have to try it first. And if we try it there, we're going to also have to make this async method a throws method. Okay? This is written a little backwards, right? You async throws a function, but you try await a function. It's a little backwards, but if you read it out loud, it kind of makes sense, right? You want to async throw, and if this had like a return, like a void, you async throw void, but you try await a task. So if you read it out loud, it kind of makes some sense. If you want to hear some serious bike shedding, go to the Swift forums and read where this was trying to be accepted. And there are hundreds of posts about trying to flip those two. So if you want some serious bike shedding, you can go do that. We can get rid of this line now, these two lines. We actually don't need weak self anymore either. We can get rid of that. We can get allow user input equal false. We can do that. We don't need the self anymore because we're no longer captured. So we do need to disable user input, though. That's what we still wanted to do. Operation queues are gone. We don't need that anymore. So we can get rid of that. We do still want this for loop. So we'll keep the for loop because we still want to go through the tiles. And for each tile, we want to do something in the game input. So we still want that. We don't need these block operations anymore. We can get rid of those. We no longer need to have this dispatch queue anymore. I didn't delete a line, right? Yeah. So we no longer need this dispatch queue anymore or the weak self anymore. We do want to, though, for each tile, set the highlighted tile, but we no longer need the self because we no longer have a captured dispatch queue. We do want the audio to play for each of these. So we're going to go ahead and do that. We no longer need this dispatch queue here, but we do want to go ahead and do the 0.3. So what we'll do is we'll say try await our task sleep for 0.3 seconds, because it's what we're really trying to do with this right here. All we're trying to do is delay. We don't actually need to dispatch to the main queue, because we were already on the main queue. All we were really trying to do is wait for 0.3 seconds. Let me get rid of those. And then here we have that, where we want to set the highlighted tile to nil. So what we're trying to do is set the highlighted tile, play the sound, after 0.3 seconds, unhighlight the tile, right? Because that kind of simulates this turning on and then turning off after playing the sound. So we do that. We want to wait for another 0.1 seconds. And this is all, if you look at all this code here, this is all just dispatch ceremony. That can all go away. But this right here, if we looked at what I just deleted, this was after the for loop. So we'll make this after the for loop. So we allow user input, or we disable user input before the for loop, and we re-enable it after the for loop. And get rid of all this, and this is what we're stuck with afterwards. So we had what we had before with Grand Central Dispatch, and now this just reads top to bottom. We wait for 0.5 seconds before we start this process, just to kind of give it a nice little animation kind of setup. We disable user input. For all the tiles, we highlight, play a sound. We're only waiting kind of like to make it look like a little bit more animated. And then we allow the user input after that kind of process is finished. And so we went from the before to this is the after. There's no longer doing the dispatch groups. We're no longer doing the enter and the leave and the wait and the guard let self equal self. All that kind of goes away. It's all done. So we have introduced this, though, and this kind of becomes kind of a trickling effect, though, right? Once we do an async throws here, we're going to start getting compile issues, because when you have a async function, it can only be called from either another async function, or we have to wrap what's calling it into a task. So if we'll see, we'll have a compile issue here, because this is calling highlight game inputs, and this is not an async function here. But we actually want to stop this here and make this just a task. So what we could do is wrap this whole thing here inside of a task. And if this is a task, it's going to kind of be the same of doing like a dispatch queue main async. This is kind of a similar aspect of doing something like this, right? But we're just wrapping it in what's called a task in the Swift concurrency world. And so this kind of sets us up here. But if we have this method here, the compile error here is saying, well, the expression is async, but it's not marked with a wait. That's an easy fix. And we're going to get another issue here saying, but it's throw. It could try, but it could throw, but it's not. We're not, handling it with a try. That's fine. We're going to do a try. If you wrap something in a task, though, and you're trying it, nothing's going to happen. It's going to just, if it does throw, the task is just going to like eat the error, right? So like nothing's going to happen. So this can throw, but the task doesn't really care. If you wanted to catch it, you can, right? We could catch this right here and do a do catch and then do something with the error here. But in this case, we don't really care. The only thing that can actually throw in this method happens to be our sleeps. And if our sleep throws, there's not much we can do about it. The sleep only throws here if it's interrupted. It doesn't show here because this is actually our helper function with seconds. But sleep only throws if we cancel in the middle of it. Cancellation's a subject I'm not going to get into for this talk. But so in this case, we don't really care. So we're just going to let the task eat the throws if it happens to do that. So we are going to stop that here. By stop, I mean we're going to stop that kind of propagation of awaits and let that happen here. And that is enough to get this compiling. So we took that long method and kind of really, really shortened it. And we're going to play this. And then we're going to start the game. And then that. And then we get purple warnings. And then we can't click it. And then, I don't know, this doesn't, it's not very functional. That kind of sucks. Yeah, all right, so we can ship this. If we go by the previous talk, that was the minimum viable product. And
I would be embarrassed by this, so it's fair.
Yes, if you couldn't hear from the audience, this would be an embarrassing 1.0, which means we are in shippable state. So we're all done. But so actually, if we come back over here and we look at all the purple warnings, this tells us exactly what the error is. It says we're publishing changes from a background thread, and that's not allowed. And so this happens in UIKit as well as it happens in SwiftUI. And what we're trying to do is we're trying to publish changes from a background thread. And that's because we have published properties up here. And if we try to do published properties on a background thread, that's not allowed, right? So in UIKit, if you try to update UI elements from a background thread, that's not allowed. And then sometimes you would get purple warnings about this. If you're unlucky, sometimes you don't get purple warnings about this, and you debug it for a day. And hopefully you're doing that on company time. And so there's several ways that we can fix this. So one way we can fix this is if we are in an async context, there's a thing called the main actor. And so what we could do is do main actor, and we could do .run. And if we do .run, this is kind of like doing a dispatch queue.main async. And so we could run all of this on the main actor. And so we could do this. We're getting problems here because what we're trying to pass is not sendable, and there's ways we can fix that too. We can make what we're trying to pass sendable, and we could do that. There's another way we could fix this. We could say we have a task that we want to create a new task, and in the task, we want to have the main actor in that task. So that's another way we could fix this. And now everything in that task is in the main actor. That syntax probably looks a little strange, but that's another way we could fix this issue. Another way we could fix this issue is by saying this method, right, and only this method, needs to be run on the main actor, right? You could write it like this or like this, it doesn't matter. So we could run that method on the main actor. Another way we could fix this is saying these properties here, like allow user input, highlighted tile, well, those should always be only changed on the main actor, right, which are these published properties, right? So these could be run only on the main actor. It doesn't matter who changes them, right? So these could always be run on the main actor, right? That's another way we could do it. And say it doesn't matter if I'm changing it or someone else is changing it. If those are ever changed, they should be run on the main actor. Even better yet is saying anything in this observable object, since this observable object is really supposed to only be used to drive UI, it should be main actor. It doesn't matter if they're properties or if they're methods. This entire class's job is to run and drive UI. So if I'm changing something from start game, if I'm doing something from reset game, if I'm doing something from action or advanced game loop or highlight game inputs, that should all be done on the main actor. And what's interesting is that in iOS 15 and above, all of these, this is true for things like UI View Controller. So if we look at UI View Controller and we tap into this, UI View Controller is an Objective-C class. But if you look at the annotation here, in a Swift UI actor, is the Objective-C name for main actor. UI view controller and your subclasses of UI view controller are already main actor. And so you can do that with your observable objects in SwiftUI by just putting main actor on the front of it. And so now, without changing any other code, if we run this again, these now will implicitly be done on the main actor. So we can write this, or we can start this again, and without any code changes other than that one line. Sorry, it's not really doing very well there. This will work now, and we get purple warnings, and everything's kind of happy, and we can continue running it. But now we've got warnings in our project, and we still have some purple stuff here, actually. Actually, I think the purple stuff might be old. But we do have some warnings in our project, and it says that we're converting a function, now that we've added main actor, that we're converting a function value of type main actor, because we're passing this function along. I'll show you how we're doing that. But now we're losing the global actor. Now that we're passing it along to a different type, we're no longer maintaining that global actor. So we'll look at where we're doing this, and we'll look at why it's a problem. So we have the game, that game observable object. And that's what's kind of driving our entire UI. To take a step back and see what we're doing in this app to begin with, we have our app files up here. We have our application. We're using the SwiftUI abstract. So we have a single state object that drives our entire application. And this is that game that we were talking about a moment ago. And so that's the game observable object that we create. We create this at the very root of our application, and we pass it into our game view as an observed object. So we do that here. I'm sorry, we do that here, game view. And then what we do is we have inside of this game, pardon me, inside of this game, we have a method here called action, and it's action for tile. So what happens if we, the user, not the game trying to show us what to do, if we, the user, tap on a tile, like right here, this is probably the wrong tile. If we, on the user, tap on a tile, it does a couple different things. First of all, it plays a sound, and then it accepts user input. It appends that to the tile, so it just kind of keeps track of what we did. And then it advances the game loop. Advances the game loop, I'm not going to dive into, but it just determines should it check that we failed? Should it check that we should go to the next tile? Should it check that we should show the next set of inputs? Whatever, it just advances the game loop. Well, this right here is now on the main actor because everything here is on the main actor. One of the slide bullet points was the fact that it's really easy now to pass async methods across as closures down the line. So we have a stacked tile view, which is this view here being highlighted. Well, this stacked tile view, if we jump over to it, and its initializer, now accepts a action. And this action has to have a tile, and it does nothing after that. It's just a button action, essentially. Well, that gets then passed down to, if we look at what this stacked tile view, this gets then passed to one of these single tiles, right? So it's an action that gets passed to one of these four. So if we look at what this is doing, it's just one of these. And so that also has that same action, and it's just a tile and void. These were working fine before because they were non-async. And it still actually works right how it is right now. It still allows you to send those downstream. The problem is now it's complaining that we're losing the main actor part of that, because that method's not async, but it's just main actor. And so now that we're having to kind of deal with that, we don't want to lose the fact that it's main actor. Well, the reason it's losing main actor isn't because we have to annotate all of these main actor, but because we're no longer allowing it to be an async method. It's losing the ability to maintain that, because in order to be something that can conform to an actor, it has to be able to yield itself. And if a method needs to yield, it has to be an async method, which means that essentially it needs to be able to pause. If it has to be able to jump back to the main actor, it has to be able to say, I can't do that yet, or the main actor can't accept me yet. Let me pause what I'm doing, and when it's ready, when the system is ready, I can then come back and then do what I need to do. So what we really need to do is, from this level upward, we need to, or the other level downward, whichever way you think about it, needs to accept that as an async closure instead. So we're compiling fine, and we're compiling fine now. As we get closer to Swift 6, there's going to be more compile time checks instead of just runtime warnings. We're going to get, or even compile time warnings. These are going to be more and more compile time errors instead of just warnings as we get closer to Swift 6. And so from here, this is already working as a main actor, but we probably should start with our stacked tile view and change this to an async method here. And we do that fairly easily. Just like we were before, we write our async here, and we can do an async throws and get this as an async method. And then now this accepts an async method. But now we can't pass this as an async method because this is async, and now we're getting a compile time that says that we can't pass this downward. And so that's kind of a bummer, but that should be a pretty quick fix too. If we look at tile view, well, tile view, we have an async method here. So we want to just change that to the same async throws. We also have a convenience initializer here to just make it a little nicer to write, so that when writing this, we can just do .green instead of having to do like a, tile.green. So we have to make sure that this escaping closure is also an async throws. And then what we have here is the fact that our button is just taking an action, right? So buttons in SwiftUI, they just take regular closures. So we can do a try await here, like it's saying. But if this is a try await, we now have to wrap this in something like a task. We're not getting an error here because I have another convenience here in a button extension that allows a button to take an async throws method. If you don't have this nice little convenience, though, what you would normally do here is just wrap this in a task. And this is a pretty common thing to do with a button. So I think in 2 weeks we're going to get this fixed. So I don't think this is long for this world, my extension, that is. I think this is going to be fixed because I think this is a little nicer to write than having to wrap that in a task.
Because you're saying they're going to bake your extension into the language?
Yeah, they called me up. So if you didn't hear, Ben asked, are they going to bake my extension into SwiftUI? And I said yes. They called me up, and they asked for my code in particular. And you can tell because there's no documentation. So that's how you know that's going to be the official one. So
No overview.
no overview available. So so now you have the button, and this populates all the way upward back to the game view. And if we get this building here, we now see that we have this now on the bottom, which is where we have game start game and game reset game. And we have pretty much the same thing here. It just loses global action or global actor, and so this is the same dance that we do here, and there's nothing exciting here. We're just going to do the same thing. So if I can type it. So otherwise, that's the same thing. And then we've got this. This does async calls. This doesn't support concurrency. And that's fine, because we could just make this an async throws. And now this here should work. And I believe here we can make this do a try await on the outside of this ternary operator. And you don't have to put it in front of each of these. You can put the try await on the outside of the ternary operator instead of putting it in front of each of those methods there. In this action, since we have that little button extension here, you can actually just pass that action straight into the action. And since it's an async throws, it will just accept it straight into the closure. So you don't have to wrap that in a task. So, and with that, we should be able to run this, and it runs just like it did before. The last thing that could be converted here is the audio player. The audio player doesn't have a lot of dispatch queue. It just has this one here. And so this is obviously something that we dealt with in the other place, where the only thing that we have this dispatch global async after, this only exists so that we could have a 0.3 second delay. So we could do a task sleep here for 0.3 seconds and kind of get rid of this whole segment here. And if we have a task sleep here, we have to try await it. And if we want to try await it, we have to make this an async throws. And that's going to throw us an error over in game if we do this. I don't know. It will eventually. So like our play sound here now has to be async. An async method here, or an await method, await call here. So we'll try await this, which means we can async throws this function. And then I believe there's one more spot right here. So then we can try await here. This try await won't affect anything because we're already in an async throws context. This try await, we had to make this async throws. I believe this doesn't matter if we make this async throws because we've already did the work just a moment ago to make all of the calls for this async throws. That's kind of what we did when we were propagating the main actor stuff. So that actually didn't affect anything. So this ended up being a pretty simple change. One thing that I couldn't get to emulate very well in the simulator, though, I don't think I'll be able to. Got to get a couple going first. Yeah, I can't get it to emulate very well in the simulator. One problem you can have on the phone, it doesn't really show up in the simulator very well, is if you tap the buttons too quickly, what's happening is since the calls to play sound can happen very quickly, since the buttons aren't locking as the user's pressing them, is these calls to play sound can overlap each other essentially. One complicated way to fix that in Grand Central Dispatch is to essentially create a lock here, and essentially lock coming into this method and unlock leaving this method, so that if you try to tap while you're still playing a sound, you will hit the lock and the sounds won't overlap. One simple way to fix that in Swift Concurrency is to make this an actor. And with a one-word change, that fixes all that, right? Because an actor will essentially lock itself. I can't demonstrate that very easily, though, because the simulator doesn't seem to have the same problem. On device, it's really easy to tap the button really quickly and have that problem. So you have to take my word for it with that one. So, but with that, the audio player will essentially ensure that you can't come into the same one too many times. So otherwise, this converts this whole thing to Swift Concurrency relatively easily. It plays pretty nicely with SwiftUI. SwiftUI itself doesn't have a ton of Swift Concurrency kind of features baked in. It is driven by Combine kind of under the hood, but the only thing it really has is the task modifier thus far. It has refreshable and things like that as well. I think with WWDC this year, we're going to see a lot more Swift Concurrency kind of baked in SwiftUI directly. So, are there any questions or anything about this or anything else with Swift Concurrency or SwiftUI?
I'm trying to formulate the question.
Yeah.
I have a question.
Yeah.
So the change that you made on the game to go from a class to an actor.
With the audio player?
When you actually change it, audio player, yeah.
Yeah.
That was a class before, right?
It was a class before, yeah.
So what is it now? Like,
it's an actor.
Okay, and how is an actor different from like the sort of the three base types that we have?
So the major difference is, so an actor is still a reference type.
Okay.
The biggest difference is an actor will guarantee that it has mutually exclusive access to its state, or has exclusive access to its own state. So if I don't have any state example here, but if something else wants to have access to its state, it has to do so in an async context. So for instance, if you have an actor, the classic example is like an actor that's a counter, and it might have a var count. If something wants to modify this count now, outside of itself, it's free to modify its own count however it wants because it knows it has exclusive access to that. But if something else wants to then modify this count, it has to do so in a way that it has to yield. So if I have something else now that wants to modify that count, it has to await that change, even if it's not an async method, for instance. So if I have like a func that says increment, right, where this, this right here just does counts plus equals 1. And if I have, a struct here, and I have, so you already saw the warning there come up, but this can't happen unless I await this. So that's a bad thing. So this right here, this is an actor isolated instance. So I can't do this unless I want to await that change. So even though this is not an async method, I have to be able to await this change, because if something else is trying to increment it at the same time, I have to be able to say, I have to wait for that increment to happen before I'm allowed to then increment.
Yeah, so you're preventing race conditions by like at the base type, not
at the compile, and it's compile time.
And it's a compile time, yeah. Right.
So before, if you wanted to do this in a in a pre-Swift concurrency world, you'd have to say, well, let me create a lock, and I'd have my ns lock or whatever kind of lock you'd want.
Yeah.
And then I have to say, lock, and let me lock here, and then let me unlock here. And you have to go through this. And even then, there's a lot of gotchas to that, especially if you're using things like collection types, like trying to lock an array or trying to lock a dictionary. This gets really messy really fast. There's ways to do it right, obviously, but there's a lot of ways to do it wrong. Yeah. And you don't get compile time checks with that. So.
Yeah, I mean, you could be in deadlock or all kinds of things. You
could also deadlock yourself very easily. This it should help prevent all that.
Right.
So. Is the ways to do that. So
it's the fundamental definition is that it's still a reference type like a class.
Correct. Yeah.
Except that it creates it enforces asynchronous access to mutations of its own state by outside types.
Absolutely. So
cool.
And actors, I think from a fundamental standpoint, I don't think a lot of people are going to be creating a ton of actors in their own code. But using the main actor is something that's going to be very common, because the main actor is just a specialized actor that we can consider an actor that is essentially an abstract over the main thread. And so sometimes we might have to await something that needs to have access to the main thread. And that's a concept that is not, that we use the main thread very often. But having a compile time check to say this has to be on the main thread, so sometimes you might have to await before you can get back to it. I think it's going to be a very powerful concept as we get closer and closer to compile time checks on that.
Yeah, you kind of a little bit answered my question, but I wanted to get more into like a task. A task is the same thing as pushing something to a main thread. That's what it is in.
So a task is not exactly the same. So a task doesn't have to be the main thread, first of all. So a task can be, so when you create a regular task, and it's just task, open, close, bracket, so that's not the main thread.
Yeah.
It's if you want to think about how it relates to like a dispatch queue, it's actually more similar to dispatch queue.global.
Okay.
So it's really not the main thread in that sense. They don't relate one-to-one with dispatch queues, and they don't relate one-to-one with threads. They're more similar to the threads than they are dispatch queues in some ways, and they're more similar to dispatch queues than they are threads in some ways. It really kind of depends. Okay. What they are, if you want to think about them in a simple way, is they're just a way to do asynchronous work. Yeah. The thing about a task, though, is it will inherit the properties. If it is being created inside of an asynchronous context, it will inherit the properties of its asynchronous context parent. So if you create a task within a task, it will inherit things like priority. It will inherit things like where it's coming from. If you just create a task out of nowhere, though, it won't do that. And there's a difference between, for instance, a task and then a detached task. And so there's a way to create a detached task as well. And the main difference here is that a detached task doesn't do the stuff that I just said in the last part of that. So it will not inherit any of the priority things from its parent. It won't inherit any of that. And so things like cancellation and stuff, it won't inherit it either. So if you have a task within a task, where you have a task, and then this task has a task, and this parent task gets canceled, this task will get canceled as well. It will get the signal to be canceled. Tasks, when they're canceled, don't immediately cancel, because they have the opportunity for cleanup and things like that. A detached task is just, it's in the Wild West. So it does whatever it wants.
If the child task in that nesting was a detached task, you're saying it would not be canceled because it's not?
As far as I understand, I wouldn't bet my life on it. As far as I understand, a detached task is in the Wild West.
Yeah.
It does whatever it wants. It has nothing to do with its parents.
So we have a question from chat.
Yeah.
It says, how would you specify a custom created thread with async await, or is that not possible?
A custom thread, I would assume, meaning more closely to like a dispatch queue in like this kind of sense, right?
Sure.
I obviously I can't get a direct answer.
Yeah.
I would assume this is the idea, and I think
yes,
that the answer that they're wanting is something more like this. You can maintain a handle to a task in this kind of way. So the way that you would do that is by holding on to a handle of a task, and then later when you do that, you can do things like task.cancel. You can do things like task is it canceled. You can do things like task, and then you can do things like there's another. No, it's those. So you could do things like that, and that's actually the same with a dispatch queue too. So when you have a dispatch queue and you create it like this and you give it a label, let's name this like T, and you create another dispatch queue with a label. These are not the same dispatch queue, even if they have the same label. So that's actually something important to keep in mind with a dispatch queue. Is just because they have the same label doesn't mean they're the same dispatch queue. So like these aren't the same thing. And so I think that hopefully that helps answer the question. So like it's obviously the same with these. The biggest difference is these don't necessarily have that, but you can actually, when you give them priorities and whatnot, that's all you really cared about, because like the IDs don't necessarily mean that much. So.
Okay.
Any other questions or?
Good.
All right. Yeah.
All right. I think that's it from chat too. So.
All right. Great. I did have, if y'all are interested, that you can get the repo. It's here, yeah. And then there's the starter project branch, and there's the finished project branch. Hopefully the finished project lines up pretty closely with what I did. So if you're interested, I think it's public. I'll check this after.